Good morning, everyone, and welcome to this webinar. Today we will focus on assessing mobile autonomous robots in France. We address the gap between technological innovations and actual applications in the field, and how agrifoodTEF plays a role in this as testing and experimentation facility. I'm Marijke Hunning, and I will assume the role of moderator today, organized as part of agrifoodTEF. So agrifoodTEF is a pan-European testing and experimentation facility that supports companies in developing and testing and validating AI data and robotic technologies in realistic agriculture and food environments. From smart machineries in the field to innovative applications in the food processing. We help bringing innovative solutions to the market faster, safer, and more efficiently. To make an impact across Europe, we actively build bridges between the digital innovation hubs and agrifoodTEF. EDIHs know their regional ecosystems, while agrifoodTEF provide access to unique test facilities, expert and knowledge infrastructure. By joining forces, we ensure that innovative SMEs and startups easily find the right support. To strengthen this cooperation, we organize target trainings for EDIHs. This way, we build multiple understanding, teach EDIHs how to recognize and refer TEF services, and strengthen their role as bridge to technological acceleration. These trainings are smart guides in European innovation system. So in short, agrifoodTEF and EDIHs bring together European technology faster in the field and on the plate. So next slide, please. The insights shared today come directly from the French agrifoodTEF test sites, and these are based on real tests, concrete results, and practical experiences. So what can you expect? During this webinar, you will get insight into how robot mobility and perception are tested in controlled environments, an overview of robot testing in vertical and arable farming, knowledge of safety testing for autonomous agriculture machines, and opportunities for collaboration within agrifoodTEF ecosystem. Do not hesitate to ask questions via the chat. We will collect them and address them during the Q&A session at the end of this webinar. I wish you an inspiring and informative session. So let's start with robotic mobility assessment and perception testing presented by Philippe Marnet and Ankur Martini.
Hello, everybody. Ankur, yeah, okay. Hello, everybody. So I am Philippe Martinet from INERIA Sofia Antipolis in the south of France. We are currently working in Ascentori. Next, please. In the Ascentori team. And we are working in autonomous machines, autonomous vehicle, and for dedicated application for monitoring the environment and agriculture. So in the framework of agrifoodTEF, we propose test evaluation and benchmarking in mobility algorithm. This means that the first step for us is to collect data on a particular area. So we are providing a first physical data acquisition. Then we provide augmentation of data, so like that it can be illustrated on the right side. This is some 1 yard which has been acquired this year, where we developed, for instance, a complete map of the environment. We can provide data with LiDAR technology, with vision technology, and for some monitoring purpose, we can here develop and use multispectral data, and also compute some different index from this particular multispectral data. What kind of algorithm in mobility we are targeting? The first one is about localization. localization by using LiDAR, localization by using vision, as a stereo pair, or using a GPS solution. We have a full ground truth system using RTK GPS, which is embedded in our complete facilities that we are using. The second part that we are targeting, that it is treated on the right side, this is mapping. The mapping can be done by LiDAR, by vision, or by RTK GPS by using some information coming from the map. Currently, we are working also, and we are specialists in simultaneous localization and mapping algorithm. So this is called SLAM. When we have localization mapping, which is done at the same time, we are able to develop LiDAR application, vision application. And for that, we have the particularity to benchmark. So this means one particular algorithm can be compared with the state-of-the-art algorithms that we have already tested on our side on a particular data set that we have acquired. This acquisition can be done before, like it is done here, for instance, what we have acquired this year, but also to the one customer place on purpose. As you will see, with our facility, we have a living lab, so we are going directly to the land. And finally, we are also interested in autonomous navigation algorithms. This means path planning and autonomous navigation as a whole functionality by using LiDAR and vision. So for us, what means the evaluation and test based on physical resources? It means first, we use a common or user data sets that we have acquired and we have already in our computer storage. We use command metric and benchmark. So we are able to rank according to some metrics, the different performance of this algorithm. We use in facilities, and we are able to go to for real test field experimentation. Next. And what we target, no, just before, please. What we target is not only to work on AI and robotic algorithm, but also to target the different application and area in agriculture, like viticulture, like arable farming, like greenhouses, like horticulture, but also arboriculture. Next. So for this, what we have is we are testing our different facilities. As you can see on the left up, we have a test bed, which is an area of 100 meter by 100 meter where we can test autonomous mobility algorithm. We have a full ground truth here at RTK GPS, which is available. We have also another parking, which is a green environment. And we have also a UAV arena when we have a sub-millimeter accuracy in order to check the accuracy, not only for calibration, but also for mobility algorithm. We have mobile robot, we have UAV, and our particularity is that we have a moving living lab, so we are able to move the laboratory to the land. Thank you for your attention.
And finally, whenever you want to test your solution, your AI or robotic solution, in terms of laboratory testing, LNE is also presenting a few facilities. So I'm Anko Matani from LNE. It's a research and testing center near Paris, and we provide two kind of facilities. The first one is this one, so it's a 100% simulation facilities. In which any kind of AI developer or perception or mobility algorithms developer can reach out to us and just ask us to build up this simulation environment. It's 100% tailored to his needs and how we can develop his solution. And we are providing him all kind of different sensors for vision and perception. It could be LiDAR, vision, infrared, or thermal, for example. And we can test it together with him in order for him to, for example, choose any kind of sensor that is adapted to his use cases, and also to provide him some new data that could be used to test the robustness of his algorithms. And that's how it helps him develop his solution and assess it in terms of performances. And of course, that's 100% simulation, so we don't have to, we don't rely on the land and we don't rely on real data acquisitions. So our partners save time and also higher up their TRL levels quite easily through simulation. And another facility, which is on the next slide, it's the robot immersion, in which you have the simulation area, which is 100% exhaustive and in which we can test any kind of obstacles or algorithms. And it's hybrid with some hardware in the loop system. So we can test the robot, host it in this kind of infrastructure, and have it run just as it would in a real land, for example. And we can test all kind of performances. For example, one important performance is the processing performance and response time. It's very important to have that quantified before going to the land and before testing it in real life conditions. We can also test all grip and ground resistance on the conveyor belts you can see here in the picture. And we can test all the complete chain of acquisition and processing up to the decision of moving the robot in one way or the other. And finally, all these evaluation and tests of embedded AI, it helps provide some simulation inputs to our partners and also test robustness against, for example, glaze. So we can simulate glaze in this infrastructure, sunlight, or even different kind of noise. And we can, of course, measure the response of the robot. And finally, all the perception edge cases that can be tested here, and also virtual destructive testing if we want, for example, to test the collision of a robot with an obstacle before going to the land. And of course, LNE is a trusted third-party assessment, so we can do it as a trusted partner also, and that helps our partners to prove their performance and also gain trust in their solution. I'm now going to give the mic to my colleagues who from EFV and Arbalis, who are going to present robot testing in viticulture and in arable culture.
Thank you and good morning, everyone. So I will start and I leave the floor to Régis for arable culture after. I'm going to start with viticulture. I work in the French Institute for Vine and Wine, and I'm going to explain how we can provide services in agrifoodTEF for robotics. Next slide, please. I'm going to present 4 use cases, and the first one is robot testing for performance assessment. Obviously, we can measure all parameters, all very important parameters to determine the global performance of a viticulture robot. For example, speed, the time it takes for the robot to make a U-turn. We can measure and determine why we have unexpected stops in the field. Is it for security matters, for network matters, and so on. And last but not least, we can measure also the efficacy, the efficiency of the task that the robot is supposed to do. And in viticulture, it's most of the time it is weeding. So we can assess the weeding efficacy. So this gives us a global assessment of the performance. The second thing that we can provide in the agrifoodTEF project is prototype development. Here we have a map which represents the experimental vineyard that we have. It's almost 15 hectares of vineyard with different kind of soil, different condition of slopes, and also all the facilities to store a robot, access to a workshop if we have to work on the robot, to make changes, also access to charging points for the electrical robots, and every facility you need to assess the performance of a prototype. Of course, we can benchmark this performance with all we know about the practices in viticulture. And this is interesting for every manufacturer, every robot manufacturer, to know how a prototype fits the end user's needs before launching it on the market. Next slide, please. So the third service we can provide in matter of robot testing is a cost and benefits assessment, because robots are meant to do the weeding essentially, but not only. And we are able now to compare the cost of use of a robot with the cost of use of a tractor in the vineyard on all aspects of the cost, like operation, maintenance, and workforce burden during the use. Of course, we can complete this cost and benefits assessment with life cycle assessment, because we have some specialists at IFV, not on our experimental vineyard, but we can collect all the data that they need to do the life cycle assessment. Next slide, please. The fourth service we can offer about robot testing in the vineyard is the agroecological approach that we can bring, because this is a big subject today. Robots are meant to use less pesticides in the vineyard, and we can compare all the production process in the vineyard with or without robots. We can assess the impact of robots use on soils compaction, for example. We can assess also the use of energy for the same tasks. Of course, we can measure the impact on chemical inputs, and of course about the impact on the efficiency. Thank you for your attention. I leave the floor to Régis for arable cultures. Thank you.
Thank you very much. Bonjour, with my French accent on my horrible English. Well, Arvalis, it's also a technical institute like EFV, like Christophe, but we are specialized in crops and mainly in wheat, maize, and also flax and potatoes. The first slide is just to show you that we can test robots in many conditions and many kind of robots. That means the small one or the big one. We have some robots testing for irrigation, for example, which weighs several tons, and some very small robots of a few kilograms. And we can test it if you are interested in flax, for example, in the north region, or in potatoes, it's mainly in the north, but we can also make tests everywhere where it's need. And you have on the map just all our stations in France. We can also offer you a large game of tests, and we will start. Yes, please. Next slide. It was a good report. The largest scale that we can offer is to test or to calculate or to estimate what will be the consequence of a robot in the crop system, in the cropping system at farm. And for this, we've got a quite good tools. The name of this tool is Sister. It's a web tool. And we have a lot of kind of different form. For example, farm with lot of wheat or other kind of farm, and we can just estimate what will be the effect of the use of a tool, for example, in the price of your production, or in the impact of in terms of greenhouse gas production, or well, many kind of indicator. In Sister, there is about 20 different indicator, or it could also have an impact of the economy you can make on the working force. And this we can calculate it. Another scale, please, the next slide. It's more centered on the tools, but on the robots. But usually we test prototype, and we test the prototype in real condition, in farming condition, and we can offer you a kind of complete test. That means if it's easy to use, how many it costs, if the design is well done, if there is any problem, for example, in a kind of soil, or what kind of slopes there is, and you've got quite a complete analysis of how the robots work on real condition on terrain. And we can, of course, the slide just show a kind of map where is the good point or the bad point of the prototype of the robots. And the next level we can test. It's example, please, next slide also. It's some component or some efficacy of component of your robot. For example, here you've got some picture of what we call weed control robots. And for example, you have a picture when there is some data sensor to control if the robots give the right pressure on the right amount of a product at the right place. So it's the map you have under. That means there is a mix between the map of data sensor acquisition and the map of presence of weed. And of course, at least we control by hand, because our job is also to go on field and just to check if the robot have a good work. And so at the last picture, you see two technical people who just check if the effect of the robot was good or not. And of course, they need to have a precise place. So they've got a pedestrian GPS, a very precise pedestrian GPS. So these are just some example of what we can do in Arvalis for your robots. That means from the insertion of the robot in the cropping system to some test of a technical part of your robot. Thank you.
Okay, thank you, Reggie. I'm Adriana Sanchez from the French Research Institute for Agriculture, Food and Environment. And I'm presenting right now the safety and performance testing for autonomous machines. Next slide, please. So to start, let's make clear that as we see that autonomous robots offer significant benefits for agriculture, and they are transforming the way we produce food. And but now I propose you to take a step back and ask ourselves, are these robots safe enough? Because robots operate in complex conditions and environments, while they must ensure safety. Next slide, please. And this is where robots testing and validation becomes essential, and it's where we come in. As through the agrifoodTEF catalog, AgroTechnopol, which is the platform involved in this project, we offer 6 agricultural robotic performance assessment tests, better known as ARPA, which are essential for your robot, to test if they are ready for deployment from the safety and performance point of view. The first 4 tests are related to safety, and the last 2 are related to trajectory performance. Take a quick overview of this test. ARPA 1, for example, helps you ensure that your robot can detect and react to static obstacles, which offers a huge advantage of reducing the risk of accidents. With ARPA 2, take us further by testing how your machine performs in hard conditions such as rain or fog, And this helps ensures that the robot operates in reliable in the social conditions. Yeah, my microphone is open. I was just verifying. Okay, ARPA-3, which is the last one from this slide, verifies that your robot stays between its working area, which enhances precision and complies with regulations against robots operating in unauthorized locations, which happens in several countries. Next slide. ARPA-4 verifies that your robot can detect humans and stop automatically when they detect them. And the huge advantage here is that that makes the work environment safer and provides peace of mind to everyone, from the farmer to the constructor. Remember that those 4 tests are designed to verify safety in robots and safety, and the last 2 tests, ARPA-PC1 and ARPA-PC2, are essential for assessing your robot's trajectory performance. ARPA-PC1 is focused in crop conditions, while ARPA-PC2 is tailored for livestock robots. That ensures a functionality and efficiency in diverse agricultural settings. Next slide, please. Thank you. So let me take a moment to share how we operate by underlying 3 pillars that shape our testing process. First, we use a strong methodology which is designed to address the company's needs and is grounded in protocols, well-known protocols that are established, and they are aligned with the ISO 18497, and also most of them are included in that standard. Second, our expert team, which they have extensive experience in agricultural robotics, and they contribute also to developing international standards. And finally, our advanced infrastructure and testing facilities that are located in the middle of France, 2 hours from Lyon, in Montautre, and that provides controlled conditions that lead to reliable and robust outcomes. Not yet, please. Of course, here is complicated to show everything. So please, if you are curious, take a look of our LinkedIn page. We post regularly from the AgrifoodTEF France and our particular LinkedIn account to see what we are doing, how we are testing, and etc. Next slide, please. So why this matters for you? If you belong to an EDIH, please keep in mind that if you are helping companies to innovate, we are here to ensure those innovations succeed by testing their safety. And if you are a company that creates robots, this is essential, testing, because we empower you with insights, with information of your robot's performance, and that enables you to take better decisions, technical decisions, strategic decisions. And at the end, we provide you with the confidence of the safety, and reliability of your robotic system. Next slide. So finally, an invitation to connect after the webinar. We will be happy to talk about your current challenges. And in the next slide, you will find our contact information. Please take a screenshot or something. That way we can be in contact. And now, please, Marek, take the lead on the Q&A section.
Yes. Thank you all speakers for this clear and inspiring presentation. So now we have time for a short Q&A session. So if you have any question, please feel free to add it in the chat or just raise your hand if you want to say something live. But I have also a question. For companies that already have a prototype, what's a typical first step to get involved with the agrifoodTEF testing services in France? So I'm not sure who wants to take that question.
I can take the first part. So the easiest way is to contact us. It could be any kind of partners or going to the website, for example. Reach out to us, set up a meeting, a technical meeting in which we both, the company and the TEF partner, understand your need. And this phase of pre-assessment is completely free. So we just want to understand what's your need, what do you want to achieve in terms of performances in your robotic system. And then we can implement something to answer your needs. And we can also find ourselves who would be the perfect TEF partner who could answer your needs. So we can redirect you, of course, to our colleagues.
Okay. Thank you.
If I can add something just
Yeah,
about
of course.
it. In fact, it is possible also that as a consortium and at the French node, we can be more than one partner to answer to the need of one customer. So we all agree to work together in order to fit the needs for the customer, in fact. And we tried to provide a bundle of services in that case that fit the needs for the customer.
Okay, thank you. A follow-up question on that then. How long does a typical testing cycle take? So from initial intake meeting to field testing?
Well, in our case, it depends. Actually, the first meeting is quite easy. Then we have several technical meetings in order to better know the technology that we are testing, the robot. And between the first meeting and the last, the results, so I think like a month. But the period for the testing is like 3 days. Takes 3 days.
Okay, thank you. And then also, are there funding opportunities or support schemes available to help SMEs and startups? So is it possible to get a reduction of cost, a cost reduction for SMEs and startups? Sorry.
So, okay, you need to know that with agrifoodTEF, SMEs and startups, they have like a full funding from the countries and from the Europe, So most of the companies will have like 100% reduction. It also depends on the organization. Certain organizations, institutions, they ask for like a percentage of that of the service, but it's a huge help, I think, that you must to enjoy or take advantage of that.
Okay, thank you. So then another question from Tommy. On the simulation service, do you provide simulation environments that companies can use in their own simulation environment? In that case, what simulators are supported?
I can answer for the simulations in LNE, for example. So the simulators we are supporting currently, it's the most famous one actually. We are working on Unreal Engine 4 and version 4 and 5, Unity, for example, and also with the robotics simulators such as 4DV or Isaacsim. So among these four simulators, we can find any kind of realism in terms of data, and that's quite, let's say, it answers all our customers' needs usually. We could provide data, and we can study if it's interesting or not to provide the complete environment. It depends on the use cases you have behind that. If the use case is only for data generation, then it's not relevant to deliver all the simulation environment, for example.
Okay, thank you. So I think with this last answer, we have come to an end of this session. So I would like to warmly thank you all speakers and their valuable contribution and insights, and also thank to all participants for your attendance, engagement, and questions. You can go to the next slide. So if you are interested in watching our webinars, the recordings are available on our website. These webinars are a great way to revisit key insights, explore practical use cases, and better understand how agrifoodTEF support testing and innovation in the agri-food across Europe. You can go to the next slide. Yeah. So to help us to improve future sessions and better respond to your needs, we kindly invite you to complete a short survey. Your feedback is extremely valuable and will help us shape more relevant and impactful webinars going on forward. Next slide. So we hope this webinar has given you new insight into the deployment of autonomous robots and that you have gained inspiration for future collaboration. If you have any further questions or would like to get in touch with any of our speakers, please do not hesitate to contact us. And we hope to see you all on the 10th of July for our next webinar on European data spaces. This webinar offers practical insights in how data spaces are already being applied in the agri-food sector today and what role they can play in ensuring efficient and cross-border data sharing. Thank you all for today.